Thanks for having me. Thank you, Charlotte, and thanks to AGI for organizing this and for the invitation to present. I very much appreciate it. This is a real hot topic, I can tell you. Right now I work at Los Alamos National Lab, but I also work part-time with the New Mexico Energy, Minerals, and Natural Resources Department, where we are examining the potential use and beneficial use of both brackish and produced waters. If you saw USA Today, you might have noticed a very large headline and study that they are publishing regarding the shortages of groundwater in the West. And that is why we're looking at this water. 15 years ago, when I started looking at produced water as a potential resource, people thought I was nuts because it can be very contaminated. And so the idea of using it, reusing it, really wasn't on the radar. And now it is. And that's because we are very short on water. The region is very delicately balanced in terms of water supplies and demands. New Mexico is completely allocated in terms of fresh water. So as climate changes and energy production changes, people move where their population changes are happening. We are getting various disruptive events like fires and floods, infrastructure failure. We really do need to look at alternative resources for water supply. So where can we use produced water? And I'll note this list is a list that I've put together not only for produced water, but for brackish water. Both of these kinds of resources they're like a square peg in a round hole. They don't fit well with our traditional concept of using fresh water and treating fresh water, delivering fresh water for use. Fresh water is our very easy water resource to implement. However, these more complex waters and more saline waters are going to be more difficult. It's going to take more effort in terms of looking at infrastructure, safe use, and regulation. So one of the most important things is availability. Is the water in the right place at the right time at the right volume? Oil and gas fields are not always located where population centers are, for example. Treatment is a big thing. It's going to be expensive. There are metals, suspended solids, scale-forming minerals, biological constituents, and organic compounds that we'll need to pay attention to and probably remove depending on the use. There's also questions about liability, risk perception, and use acceptance. Who owns the water? Does it belong to the surface owner or the mineral rights owner? And who bears the liability if something undesirable like a spill happens? There may be skepticism in terms of human uses like irrigation. Holly was talking about this. We could even say drinking water. What if we took this to drinking water standards? It is possible, but it's probably way too expensive, and there's likely to be questions. However, there are other uses, industrial use and possibly biofuel production and co-product production from biofuels where this water might be very useful. We have to be safe and consider the environment when we are using this kind of water, and there's a number of considerations, not just spills, but also the operations, non-impingement on freshwater resources. If we extract brackish or produced water, we don't want to also co-extract fresh water. What's the long-term sustainability of the resource? Are we going to have to plan for obsolescence? And then what kinds of hydrologic studies and regional basin studies might we need to understand this water use in the environment? Policies are adapting, as we've seen, and regulations are adapting. There are regulations that may promote or inhibit the use of these waters, and we're going to have to take a close look at those and make sure they fit the type of water that we have. There's also a market. You have to have a customer who will buy the water, and they're probably going to want to buy it at the right price. Scarcity, however, tends to make the perceived price of water go up. If you think you've got a scarce water supply, then you're going to be willing to pay more. Infrastructure investment, we will need somewhat different infrastructure to prevent spills. This incurs more costs. There's, of course, transport, treatment, waste disposal, et cetera. And then how do you finance this, either public financing or private financing or with partnerships? So there's a lot of things that will need to be considered. There's a lot of moving parts. In New Mexico, we've been looking at the regulatory framework for reuse, and Holly gave a nice start to this. On the left-hand side of the screen, I've shown the areas that are under the jurisdiction of the New Mexico Oil Conservation Division, And as Holly mentioned, we have new regulations for recycling and reuse. As long as this water stays within the oil and gas production and operation, there's no permit needed, although there are specific requirements. You can treat this water and put it back into the system. The waste disposal process also stays in the system, and uses case by case are also able to be considered. However, once we treat this water or move it over into the freshwater regime, which is governed by our state engineer, then we start looking at a completely different system, a completely different regulatory system. We have water rights and water permits that are important. And of course, if there's a spill, our environment department takes over and has jurisdiction there. And again, the liability issue comes into question. So there's a lot of things along that fuzzy dividing line down the middle that will need to be looked at and better defined so that we can use these waters. Some alternative uses for produced water. As I mentioned, reuse in oil and gas production is a really logical place for produced water to be used. There's a clear regulatory pathway. Hydraulic fracturing is reusing produced water quite a bit right now. And there's also some other examples. I'll bring up one called about steam flooding that's being done in California and some of the oil fields there. Irrigation is one that's always brought up. I hear this all the time. After treatment or dilution, irrigation is a potential use for produced water. I will show an example of rangeland rehabilitation, some work that was done at Los Alamos and Sandia with some small businesses several years ago in northern New Mexico. And then, of course, the most recent study on growing a non-food crop, which is cotton. Algal biofuel production is something we've looked at as well. This is an interesting and somewhat new way to look at using produced water. It's like a new energy versus old energy. And then another example might be potash mining. This has been proposed but is not yet enacted in New Mexico. However, I'll note that solution mining using saline water is a very good way to extract potash. Right now they're using brackish water. The alternative would be that they would use fresh water with added salt. And so we prefer that they use water that's already salty rather than taking up fresh water. So it's a potential good use of produced water if we can get the quality issues resolved. For hydraulic fracturing, there are a number of reuse criteria that are important. They may not always be what you think would be important. Of course, some of the critical treatments would include removal of solids, total suspended solids, free and colloidal oil. Microbe removal is very important. Uncontrolled microbial growth in wells can cause corrosion and clogging and other problems. Iron and floc formation is very important. Need to get the iron out. Ion balance is also important both for formation interactions and mineral scale inhibition. And then boron is a problem for the additives they use during fracturing. Less critical is pH and salinity. Hydraulic fracturing processes now can utilize very high salinities, which is a good thing because salt removal is very expensive. There's a number of treatment options that are out there for saline waters. I won't get into this a whole lot, but bear in mind that membrane methods are usually the most common methods we know of. They are usually used for seawater. That's the type of desalination that we know the best. Always bear in mind that there is a concentrated waste that must be disposed at a cost when you do a separations process like a membrane method or a thermal method. You will have some fresher water, but you also will have a waste. And so when you're inland, that means injection for disposal or perhaps evaporation ponds. Thermal methods are starting to be used more frequently. This is just a fancy way of boiling water, essentially, making sure that we control the heat and the thermal processes. Solar thermal is something that's also a potential new way for separating fresh water from saline water, and it is being used for produced water. Again, you also have a concentrated waste that you're going to need to dispose ultimately. And then there are some hybrid methods, membrane distillation and low temperature thermal distillation. Some of these have some improving cost profiles, which is a good thing. Also electrocoagulation and capacitive deionization are possibilities. However, they're most useful for specific constituents or lower salinities. And I could answer some more questions about these methods, but we'll keep moving along. I want to thank Kent Adams from Bobco. They recently did a study where they looked at the costs of freshwater consumption versus produced water consumption, both with treatment and without treatment, for a frac job. Their goal was to retain 100% of the produced water and retain the efficiency of their cross-linked gel so they could extract more gas. Fresh water has a cost, and in this case, they did not need to utilize fresh water, so that eliminated that cost of $250,000. They decided to try some treatment. Electrocoagulation was more expensive. They also did some just basic filtration, which was less expensive. Water transport costs were where the biggest cost was incurred, as well as pumping. So those are not necessarily something you think of immediately as a key for cost, but when you look at the final bottom line, the costs are not that different, and so reuse without treatment and without using fresh water is a very feasible option. Steam generation and aquifer recharge is done right now in San Ardo field in California. This is a heavy oil field. They are using reverse osmosis treatment to create water that is both discharged to basins for aquifer recharge and then for a steam generator, which has very high quality requirements. They're getting 75% recovery while reducing total dissolved solids and boron. They have a fairly complex process with oil removal, softening, filtration, and RO. So ultimately, they're able to retrieve 50,000 barrels per day of treated water for discharge. And I've got the reference here if you're interested in looking this up. Veolia is the company that's doing the work. The rangeland rehabilitation was work we did in Bloomfield, New Mexico. We had a coal bed methane water, not that salty. We did a number of steps. Used a modified zeolite to remove coal fines and organics, and also dissolved turbidity and total iron. And this was a collaborative effort between ConocoPhillips and some small businesses, and was very successful. We had a temporary permit for rangeland rehabilitation up here. Cotton production was done using produced water. Katie Lewis is the researcher at Texas AgriLife. Just finished their study, I think, at the end of November. And they used a blended water, well water and produced water. Interestingly, the treated produced water was much lower in salinity than the well water that they used at the site. The treated produced water was actually an improvement on the water quality. It reduced the salinity, and they had improved growth with blended water. So a very interesting study. Finally, the algal biofuels. We took a look at where water needs would be for cultivation of algae. Algae for biofuels is going to need a lot of water. Fortunately, it doesn't need fresh water. So we looked at where there is very high evaporation, along with the needs for the algal biofuels. We also looked at where the oil and gas producing areas are in the gray. So the water needs are highest, of course, where the red is. We took a number of samples from different wells in different parts of the state. Ended up doing some work down in the southeast corner with the folks at El Dorado Biofuels. And what we found is that we could take produced water, we could treat it using a multi-step process. This did not need to have salt removal, but we did some organics removal and reduction using filters, oil water separator, and stack scrubbing. And ultimately, we were able to use produced water for both lab pilot and also some field scale tests, and we had good recovery of algae and biofuel. We did find that high salinity tended to reduce our growth, and we also got very good quality when we started looking at additional uses of the algae for stock feed, for example. So the algae grown in produced water was just as good as algae grown in fresh water once we harvested it and took a look at it. So a lot of possibility there. I've included my contact information here, and then I've also included information for Katie Lewis as well, and I'm glad to answer any questions. Thanks.